Next, we're going to look at solving an equation. Solve and check. 4x plus 5 equals 29. We're trying to solve this equation for the variable x. To do so, we're going to use some properties of equality in order to get x isolated on one side of the equation. First of all, we note that we can subtract 5 from both sides of the equation in order to leave us with our term that has x in it. So that looks like this: 4x plus 5. We're going to subtract 5 from the left-hand side and from the right-hand side of the equation. Subtraction of 5 on the left will leave us with 4x. On the right-hand side, subtracting 5 leaves us with 24. Now, because we're multiplying by 4, in order to undo the multiplication by 4, we use the inverse operation, which would be division. That is, we're going to divide the left-hand side by the value 4, and that will still be equivalent to our other side of the equation as long as we also divide it by 4. 4x divided by 4 is x. 24 divided by 4 is 6. Now we want to check our solution. To do so requires us to take the value that we just found and substitute it back into the original equation to see if we come up with our value of 29 on the right. We're going to have 4 multiplied times 6 plus 5. The question is that equivalent to 29? Well, 4 times 6 is 24 plus 5, and 24 plus 5 is 29. And so our solution checks, and the solution to the equation is x equals 6. Here's another equation to solve. Solve and check. 6 times x minus 3 minus 10x equals negative 10. We'll begin by using the distributive law in order to simplify this group of where we have parentheses. We're going to have 6 times x minus 6 times 3, and then we have minus 10x, and that's equal to negative 10. Let's go ahead and evaluate. We have 6x minus 18 minus 10x equals negative 10. We want to simplify one side of the equation as much as possible in working the problem. So we're going to next notice that we can combine our 6x and our minus 10x. 6x minus 10x is going to give us a negative 4x. The subtraction of 18 will move down to the next step. Now we want to see that we have a single term that has x in it. We can start by adding 18 to both sides of the equation in order to isolate it. We'll have negative 4x minus 18 plus 18 equals negative 10 plus 18. On the left-hand side of the equation, the 18s will subtract out, leaving us with negative 4x. On the right-hand side of the equation, negative 10 plus 18 is 8. Now we can divide both sides of the equation by negative 4 in order to solve for x. Negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. Let's now take this solution and substitute it into our original to see if it's a valid solution. So we have x equals negative 2. We'll have 6 times negative 2 minus 3 minus 10 times negative 2. And we're interested in whether that result is equal to negative 10. Let's work within parentheses. We'll have 6 times negative 2 minus 3 is going to be negative 5 minus 10 times negative 2. 6 times negative 5 will give us negative 30. A negative 10 times negative 2 is one way to think of it. We're adding here negative 10 times negative 2, so that would be a positive 20. And now negative 30 plus 20 is negative 10. And so we were able to check our solution and see that the result of negative 2 is correct. Now let's look at another equation to solve. Solve the equation 2x plus 9 equals 8x minus 3. In this equation, we'll note that we have variable x on both sides of the equation. Our first step can be to try to put our terms that have x in them on the same side of the equation. Now we have two options. We can end up trying to get the terms with x on the left-hand side of the equation, or we can try to get the terms with x on the right-hand side of the equation. If we choose to move the terms to the left-hand side, we're going to accomplish this by subtracting 8x from both sides of the equation. So we can write down 2x plus 9 minus 8x equals 8x minus 3 minus 8x. We can now combine our like terms. 2x minus 8x is negative 6x. We'll have our plus 9 move down. Our 8x's will subtract out on the right, leaving us with negative 3. Now to isolate the x term, we're going to subtract 9 from both sides of the equation. Negative 6x plus 9 minus 9 equals negative 3 minus 9. On the left-hand side of the equation, the 9's subtract out, leaving us with negative 6x. On the right-hand side of the equation, negative 3 minus 9 is negative 12. Now to end up isolating x, we're going to use the inverse operation of what's going on right now, which is multiplication. We have negative 6 being multiplied times x. If we take negative 6x and divide by negative 6, we'll take the right-hand side and do the same. On the left-hand side, we come up with our value of x, and on the right-hand side, we come up with our value of 2 as the solution. Now let's look at solving another equation. Solve and check. 4 times 2x plus 1 equals 29 plus 3 times 2x minus 5. We have some parentheses that we can take care of by using the distributive law. 4 multiplied times 2x will give us 8x. Plus 4 multiplied times 1 will give us 4. On the right-hand side of the equation, 29 plus 3 multiplied times 2x gives us 6x. 3 multiplied times the 5 is going to be 15, and we'll be subtracting that. Now let's combine like terms on the right. We have 8x plus 4 equals 6x, and we're going to have 29 minus 15, which will give us plus 14. Now we notice that we have a term that has x in it on the left and a term that has x in it on the right. We want to get those terms on the same side of the equation, or think of it this way, we want to subtract 6x from both sides of the equation in order to have only x variables on the left. So we're going to rewrite this as 8x plus 4 minus 6x equals 6x plus 14 minus 6x. 8x minus 6x is going to be 2x. On the right-hand side, the 6x subtracts out to leave us with 14. Now, to isolate the x term, we'll subtract 4 from both sides of the equation. 2x plus 4 minus 4 equals 14 minus 4. The 4's subtract out on the left, leaving us with 2x. 14 minus 4 is 10. Finally, we can divide both sides of the equation by 2 in order to have x by itself. Our x value is equal to 5. Now we want to check this solution. We'll take the value of 5 and substitute it in the original equation for x. 4 times 2 times 5 plus 1. We're trying to figure out whether that's equivalent to 29 plus 3 times 2 times 5 minus 5. Let's work inside the parentheses on the left. We'll have 4 times 2 times 5 is 10. On the right-hand side, we can do the same type of procedure. 2 times 5 is 10. Adding 4 times 11. On the right-hand side, 3 times 5. 4 times 11 is 44. 3 times 5 is 15. And 29 plus 15 is 44. So our solution checks. Now we're going to solve a linear equation. Solve and check. 2x divided by 3 equals 7 minus x over 2. Here we have an equation with fractions. We can use the least common denominator of 6 in our second step in order to rid the equation of those fractions in the following manner. Let's multiply both sides of the equation by 6. 6 times 2x over 3 equals 6 times 7 minus x over 2. Let's go ahead and simplify here. I'm going to write this as 6 times 2x over 3 equals 6 times 7 minus 6 times x over 2 using the distributive property. To multiply on the left, we can think of this as 6 over 1. We have a common factor of 3 that will divide out. 3 divided by 3 is 1. 6 divided by 3 is 2. 2 times 2x gives us 4x. On the right-hand side, 6 times 7 is 42. And in a similar manner, we think of this as 6 over 1. 2 divided by 2 is 1. 6 divided by 2 is 3. And end up with minus 3x. Now we want to combine our variable expressions. We can do that by adding 3x to both sides of the equation. 4x plus 3x gives us 7x. On the right-hand side, when we add 3x, we're left with the value of 42. Now we have 7 multiplied times x. We can undo the multiplication by using division. 7x divided by 7 is going to give us x. 42 divided by 7 gives us 6. To check our work, we take our value of 6 and substitute back into the original equation. We'll end up with 2 times 6 divided by 3 equals 7 minus 6 divided by 2. We're questioning whether this statement is true or not. Let's simplify the left-hand side. We end up with 12 divided by 3, which is equal to 4. Is that going to give us the same result as 7 minus 6 divided by 2, which is 3? Yes, 4 does equal 4, and therefore we've checked our solution. Now let's see how to use algebraic expressions and a line graph. The formula d equals 10/9 x plus 53/9 models the level of depression, d, in response to the intensity of a negative life event, x, from 1, which is low, to 10, which is high, for a low humor group. If the low humor group averages a level of depression of 10 in response to a negative life event, what is the intensity of the event? And how is the solution shown on the graph? Now, to understand what's going on with this problem, we need to really understand what our variables stand for in the formula. D, we're told, is going to model the level of depression. And x is going to stand for the intensity of a negative life event. We're told that our value of x can range from 1 to 10. In the question that's being asked, we're told that the level of depression is 10. So therefore, in our equation, D stands for level of depression. We're going to make a substitution for the value 10 for D in this equation in order to figure out what our value of x would end up being. Let's do that now. We're going to then have to solve the equation 10 equals 10/9 x plus 53/9. Now let's do that, and then we'll come back to the problem to see what this is going to be giving us. Because we have fractions in the problem, we can choose to multiply both sides of the equation by that denominator of 9. That will be 9 times 10 equals 9 times 10/9 x plus 53/9. 9 times 10 is 90. On the right-hand side, we'll use distributive property. 9 multiplied times 10/9 is going to be 10, and then times x will give us 10x. Plus 9 multiplied times 53/9, the 9's will cancel, giving us 53. Next, we're going to notice that we have one term that includes x. We're going to subtract 53 from both sides of the equation in order to isolate that term. So we'll have 10x plus 53. We'll subtract 53 on the right and subtract 53 on the left. When we subtract 53 from 90, we end up with a value of 37. Subtract 53 on the right, we are left with our 10x. And now divide 37 and 10x by 10 in order to get our solution. X is equal to 3.7. Now let's go back to the problem to see what we found. The x in the problem was equivalent to the intensity of a negative life event. And we came out with the following. We had that D was equal to 10, and we had that X was equal to 3.7. This chart you'll also find in your textbook. To use the chart, what we would be doing is noticing that the value for D is going to be given along the vertical axis. The value for X is given along the horizontal axis. We're going to take the value of D, which was 10, we're going to move over to see where it intersects with the line graph, and then move down. And what you would see is that the X value of 3.7 is going to look like it's accurate, and it would be the point on the graph that corresponds to where we're forming this rectangle from our D value down to our X value. Now let's look at solving proportions for our next problems. Solve each proportion for X. In part A, we have 10 over X equals 2 over 3. It's a proportion because we have a fraction equals a fraction. To solve the proportion, we'll cross multiply. We're going to multiply across, giving us the product of 10 times 3. We'll multiply going across here. That would be X times 2. So we're going to have 30 equals 2X. Dividing both sides of the equation by 2 gives us a value of 15. So 15 is equal to X. That would read 10/15 is equal to 2/3. In part B, we have 11 divided by 910 minus X equals 2 divided by X. Using our cross multiplication, we multiply 11 times X. That's going to equal the product of 2 times 910 minus X. Now, to evaluate this, we're going to use our distributive property of multiplication over subtraction. That's going to give us 11 times X equals, we'll have 2 times 910, which would be 820, minus 2X. We can now add 2X to both sides of the equation. That's going to give us 13X equals 820. And then we'll divide both sides of the equation by 13. And you could do this by hand or using a calculator to come up with our answer of X equal to 140. In our next problem, we're going to solve a word problem by using proportions. The property tax on a house with an assessed value of $45,000 is $600. Determine the property tax on a house with an assessed value of $112,500, assuming the same tax rate. We'll begin by representing the unknown by X. What we're trying to determine in the problem is the property tax on a house with an assessed value of $112,500. That makes sense to let that equal X. So let's let X equal that unknown property tax. Next, we're going to set up a proportion. In our proportion, we know that the assessed value of one house let's say of house 1, divided by the property tax on house 1 will be equal to the assessed value of house 2 divided by the property tax on house 2. Now, let's put in the values that we know. We know that the assessed value of house 1 was $45,000. The property tax on that house was $600. The assessed value of house 2 is $112,500. And the property tax on house 2 is what we're trying to find. That's our unknown property tax. So we're going to let that equal X. Now, step 3. In step 3, we want to drop the units and apply the cross products principle, which is that cross multiplying. We're going to drop the units and have 45,000 divided by 600 equals 112,500 divided by x. In order to evaluate this, we can cross multiply. We'll multiply 45,000 times x, and we'll multiply 600 times 112,500. Now that value would give us 67,500,000. Then we can divide both sides of the equation by 45,000 in order to come up with our result. And we can use a calculator to evaluate this. Our answer is 1,500. We've solved for x, and therefore we want to answer the question now. And the question then, recall, had to do with the property tax. So the $1,500 would end up being the property tax on our $112,500 house. Now let's look at a word problem dealing with population of wildlife. Wildlife biologists catch, tag, and then release 120 deer back into the wildlife refuge. 2 weeks later, they observe a sample of 150 deer, 25 of which are tagged. Assuming the ratio of tagged deer in the sample holds for all deer in the refuge, approximately how many deer are in the refuge? Step 1. Let's represent the unknown by x. Well, the question we're trying to answer is, how many deer are in the refuge? So let's let x equal the total population of deer. Now we need to set up a proportion. The proportion is going to have to do with the following. The number of tagged deer compared to the total population is going to be equal to the number of tagged deer in our sample compared to the number in the sample. That's what's meant by this statement, assuming the ratio of tagged deer in the sample holds for all deer in the refuge. We have the same ratio going on here. Well, we are told that the number that are actually tagged in the total population is 120. The number that we actually have of deer is our value x. The number tagged in the sample, 25. The number in the sample, 150. In steps 3 and 4, we're going to apply the cross products principle, solve, and answer the question. So rewriting the equation, we have 120 divided by x equals 25 divided by 150. Now, one thing we can work with as we're working through our proportions is the fact that we could reduce any fraction that we see that can be reduced before we do our cross products principle. Let's apply that now. We'll have 120 divided by x equals 25 is a common factor here. We'll divide the numerator by 25 to get 1 and the denominator by 25 to get 6. Now when we apply the cross products principle, we'll have 120 multiplied times 6 equals x times 1, and 720 will equal x. So to answer the question, the 720 would equal the total population of deer. We'll just say that we have 720 deer in the refuge. Now let's look at another equation that we're asked to solve. This time the equation is 3x plus 7 equals 3 times the quantity x plus 1. Well, we notice on the right-hand side that we can use distributive law. We'll have 3x plus 7 on the left equals 3 times x plus 3 times 1, which is just 3 on the right. In our previous steps, we've always been trying to get our x terms on one side of the equation. We notice that we have a 3x on the right that can be subtracted in order to isolate it, or to eliminate it, that is, from the right-hand side of the equation. So we're going to subtract 3x from both sides of the equation. Now let's combine like terms. 3x minus 3x, well, that's going to be eliminated, and we're left with 7. On the right-hand side, we subtract 3x, and we're left with 3. However, when we look at this result, we know that 7 does not equal 3. In fact, this statement is never true. And so using that same reasoning, that must mean that the original equation is never true. And if that's the case, then we have to state that there is no solution to this equation. Here's another equation that you're being asked to solve. 7x plus 9 equals 9 times the quantity x plus 1 minus 2x. We notice that we can use distributive law on the right-hand side. That would be distributive property of multiplication over addition in order to eliminate the set of parentheses. So 7x plus 9 is going to equal 9 times x plus 9 times 1, and then we have a subtraction of 2x. On the right-hand side, we see that we can combine like terms. 7x plus 9 equals 9x minus 2x is going to be 7x, and then we have plus 9. Now, at this point in the problem, let's just stop for a moment. 7x plus 9 equals 7x plus 9. When would that be true? That would always be the case. However, let's say you don't recognize that at this point. If you continue with your typical process, you would try to perhaps subtract 7x from both sides of the equation. Let's just go on and go with that. 7x plus 9 subtract 7x equals 7x plus 9 subtract 7x. Subtracting 7x from the left leaves us with the value of 9. Subtracting 7x from the right leaves us with the value of 9. Now there's no variables left in the problem. When does 9 equal 9? Well, this is always true. And that line of reasoning, if we back up, of course, 7x plus 9 is always equal to 7x plus 9. This is also always true. It turns out that the original equation was an identity. That is, a statement that is always going to be true.